Hey everybody, I'm Chad Stewart. I am a software engineer from Kingston, Jamaica. And in today's video, I'd like to go over a framework that I use to solve algorithmic interview questions. So pretty much through my own research, I've gone through kind of several ways of how to approach an interview problem, and I came across several documents, and I'm the type of person that likes to tinker with things, especially with like kind of like ways to do things. And so after a lot of research, I kind of ended up coming up with this quote unquote framework. It's not like an official thing or anything. I try to use it whenever I can. At the very least, it kind of gives me an idea of how to view the problem and what steps where I am in the steps of how to view the problem, and it makes solving the problem significantly easier. Obviously, if the problem is outside of not necessarily your wheelhouse, but if you don't have like the basic knowledge of solving the problem, it won't necessarily magically make you be able to solve the problem all of a sudden, but at the very least, it will kind of give you an idea of where you're having a problem in the problem. Trying my best not to laugh at that, but it gives you a good idea of where you're at, and where potentially you're having hiccups. And it like my intention is whenever I'm solving these problems to actually use this framework and give all this documentation to the interviewer. So now they have like pretty much a full documentation of my process through to solving the problem, and all the things that I went through. Obviously, the interviewer would be with me during the interview, but it would just kind of go through my entire process, right? So it helps you to kind of formulate your thoughts into solving the problem, and then it helps the interviewer, see where you are, and then for places that actually take what you write and then use that to kind of make a decision on whether or not they want to hire you. Now they have a lot more information to have. They have a lot more information to scrutinize, as opposed to just the code you wrote and in essence what the person said. So I'm going to go through the framework right now, and then I'm going to go through a problem that I use the framework for, and just kind of give you an idea of how it works. So let me click on this, and yeah, sorry. Nope, that is not what I want. There it is. Okay, so this is pretty much the skeleton. Almost said skeleton. Funny way of saying skeleton, but this is just a skeleton of the framework. Pretty much, I'm going to explain each section. Yeah, I'm going to explain each section. I'm going to explain the reasoning behind the section, and yeah, like also I'm going to make the framework available on a guest available on a guest, which I will add to this video or to the video description. So you can download it, you can use it, you can play around with it, you can tell me it's absolutely terrible and why did you make this in the first place. But yeah, like I'm just hoping that this kind of helps people, kind of especially in practicing. Anyways, let me get into it. So pretty much the framework is, the idea is, you take the problem statement, you try to understand the problem as best as you can using examples, and then from there you write a procedure on how to solve the problem, and if you can, you talk about the space and time complexity of your solution. And then you try to optimize the solution, and then you write code, and then you test, right? The big thing about this framework is to give you as much time to think about and come up with a solution before you write code. Um, Through personal experience, what I have found is that the moment you start writing code, you start kind of putting yourself in a box, and it's really hard to get out of that box once you put yourself in it. And this is even before the time limit of the what you call it, of the coding interview. So really and truly, this is kind of to give you the space to really think about the problem as much as you can, get as much information from the problem as you can, think about the problem as much as you can, and then start writing code. And then the writing code would be pretty much you just taking everything you've thought about and then just transcribing it into whichever language. So, um, let me see. Right. So the first thing is a problem statement. You want to write the problem statement here. You preferably want to write it in your own words, so the interviewer will give you the problem. You you immediately want to put that problem here. Yeah, you want immediately want to put that problem here, and put it in your own words. The interviewer will probably tell you, oh, that's not exactly what I said, or that's not exactly what I mean. You kind of just want to get to a point where both you and your interviewer kind of agree on on the statement, on the problem statement here, right? And then from that you start going into examples, and this is to help you understand the nature of the problem. So you do whatever examples that you can, here, obviously. So something that I've recently started doing, and I would most definitely recommend any person who is interviewing to do, is to draw out to draw, like, diagram the problem as much as you can. There are a lot of problems that become significantly simpler to kind of view, to kind of think about, once you literally have them kind of drawn out on either a whiteboard or in your machine or whatever. But once you kind of have like a physical representation of the problem, it's usually significantly easier to reason about. Like, significantly easier. I've personally been working on dynamic programming problems, and they are so much easier to work with when you draw out the kind of problem space. I won't get too deep into that, but either way, you will put your examples here, right? And you go through your interviewer, and you just kind of go through the examples, and you're just like, oh, is this what you mean? And you try to discern as much information as you can. These two sections, mainly, actually three sections, these three sections mainly are to discern as much information, as much leverageable information as you can from the problem statement. So you have the problem statement, you have the examples, and then when you're going through the examples, there's just a section here for notes, right? You can put any notes here, and this is just to kind of make sure that, maybe anything that you covered that's not necessarily in the problem statement. Problem statements tend to be, are purposefully ambiguous, unless they're like from LeetCode, because you can't talk to anybody. But a lot of times when problem statements are given to you, they are purposefully ambiguous, so you have to ask questions. And a lot of the times, in your trying to go through examples, you will come up with something, and then you may ask the interviewer, what do you mean here? And then they'll answer it, and you can put this in the notes section here. And so these three sections are here to pretty much get you to understand what you're trying to do. So the next thing here is a proposed procedure, and pretty much you write a procedure on how to solve the problem. When I write the procedure, and I'll show you an example. When I write a procedure, I write it like 1, 2, 3, 4, and I write it in plain English. Like, I don't even necessarily do pseudocode. I write it in absolute plain English, and I tried to make the procedure as close to code as possible in plain English. But the point is to, like, what steps would you need to take to solve the problem, you know? and the procedure should more or less solve the problem as, I don't want to say as exactly as you can, because I don't want to tell you to worry about implementation details. In fact, you don't want to worry about implementation details. Like, in essence, if you had a magic wand and you waved the magic wand and the magic wand literally took your English statement and made code, magically made code, you know, you want to be able to tell the magic wand what you can do, what it needs to do, right? So, like I said, when I write it like step 1, step 2, step 3, and in flushing this, in, you know, coming up with the procedure, fleshing this out. In fleshing this out, you will also potentially find problems, and you can just kind of fix it immediately. But you're not as boxed in as to writing code. You're not nearly as boxed in. You can be like, okay, maybe this procedure doesn't work, and so on and so forth. Once you're finished with the procedure, um, let me talk about why I have it step by step. So I have it step by step so that it becomes significantly easier to transcribe the procedure into code, because that's literally what you're doing. You're literally transcribing the procedure. So you're thinking about it as how the computer would solve the problem, which is why I mentioned the magic wand earlier. You're thinking about it in terms of how the computer would solve the problem, but you're not using code to do that yet. You know, you're in essence still trying to kind of give yourself a physical representation of your attempt to solve the problem so that it's significantly easier to reason about. Anyways, in terms of that, one of the big things that always gets asked in these algorithmic interview questions is, what's the space and time complexity? And so I just kind of put that down here, and it's like, what's the proposed space and what's the proposed time complexity? So there's also a note here that a brute force method is a brute force procedure is preferred here, right? So the reason why I say that is, in essence, the first thing that comes to your mind, write it down as a procedure. Absolute first thing, right? And I will explain why in a minute. But however, as long as it solves the problem, it doesn't matter if it's not the most efficient solution. It doesn't matter. Like, the most, whatever solution that you can come up with that actually solves the problem, that you know will solve the problem, you put it there, right? And then you propose the space and time complexity of that proposed solution. um so some some people will say, there's like, I don't want to say an argument, but there are points where it's like it's better to have working code than to have, not working code that you attempted to optimize. The way the framework is designed now, it's to get to optimize code before you to get to an optimized procedure before you write code. This is where, again, you can play around with the framework as much as you want. If you want to write code first, so if you want to write your brute force solution first, you can put it here. You can start writing the brute force solution here, so at the very least you have code. And then and I go through all of that to say that there's always a question of, can this procedure be optimized? And then you want to literally answer that here, right? So in essence, if the interviewer was going to ask you, and they usually ask you, can this procedure be optimized? You want to answer that question. Sometimes it can be, sometimes it can't be, but this is to demonstrate that you understand the space and time complexity, and you understand the trade-offs of space and time complexity, and you understand what is the most optimal solution for like a particular thing, for a particular problem. Sometimes, like, well, you know what? Yeah, let me go with that. You can come up with the most optimal solution. You understand why it's the most optimal solution, right? um or you understand why it's an optimized solution. Let's go with that. You understand why it's a optimized solution, right, as opposed to optimal. Because you may not necessarily come up with the most optimal solution, but you may come up with a very optimized solution, you know, and you just want to be able to talk about that. So you can talk about why it's not optimal, here. If it is, you don't have to worry about this section. Um, if it's not, and now actually in the example that I will show later, is that there isn't a way to optimize that further. At the very least, time complexity wise. Then I didn't think about whatever. I'll talk about that, right? So after you've gone through this whole thing, you try to come up with an optimized procedure, right? In this version of the framework, this framework is ironically optimized to come up with optimized code before before writing code, right? And so you can come up with an optimized solution here, and then you try to solve for the problem of time complexity. Generally, that's what you're trying to try to solve for. And yeah, and then you talk about the optimized space and time complexity. A lot of the times when you're optimizing for time complexity, your space complexity tends to get larger to compensate. But yeah, like that doesn't necessarily mean that it always is like that, but that tends to happen. Anyways, so you have your procedure, right? And so here in the solution attempt, this is where you write your code, right? Code goes here, and I'm going to give some examples of code that would be great for interviews. But generally, you want to write clean code. You want to write code that is very self-descriptive. Again, which is why I write the procedure the way I write it, because it helps make the code helps writing the code cleanly, right? Because when you're transcribing it, you're just literally writing what the statement says, and it just helps to write the code more cleanly. And even when I'm writing the procedure, you're not going to see it in this example, but even when I write the procedure, I could not concatenate. I put I tab. I don't even remember why I don't remember what the statement is, but like I will put spaces in terms of, so like for instance, let me actually give an example here. So like for instance, step one, blah blah blah. No, I messed everything up. Step one, blah blah blah. If there's a bunch of things in this step, I will add spaces here, and then I'll go through more blah 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 blah, and then I will go to the next step. You know what I mean? So right, and that's pretty much. I really didn't want this to happen. Give me 1 second as I clean this up because this is annoying. Don't save. New file. Yeah, I just don't want all the yellow squigglies because it's a little bit annoying and distracting. Anyways, write code. You want to write your code, and then you want to write it as cleanly as possible, as legibly as possible. Also, I would highly suggest you write it modularly, so that it's easily unit testable. It's easy to edit. Some interviewers will want to give you additional questions. Oh, what if it makes it easier to change your code as opposed to just kind of writing it all in one function. you know Pretty much write clean code. That's pretty much write clean, easily readable code. You will get a lot of you'll get it'll be better for you as a person writing, and it'll be better for the interviewer as a person reading. you know and it shows that you think about these things. You think about code readability. You know what I mean? And writing good, well-structured code. Anyways, so tests go here, right? So now you want to go through your test. You finished writing your code, you feel that it's correct, you want to test your code, right? Um, so I played around with this personally in terms of I wrote, tests as close to, so I write in JavaScript, so I wrote tests in as close to jest as possible. Um, so I did that to show that I could write tests. And in fact, there was a version of this framework where the tests came first, or not first. It came where the examples were, they were tests. So the goal was to try and understand the problem so much to to be able to write tests on the code, and it's kind of like a TDD type thing, you know. I since kind of moved away from that mainly because I feel like examples and tests are two different things, and I think it's easier to write tests on the when you have code, at least in this format. You know, like I think TDD there's a few other things that you would need before writing tests, and either way, yeah, that's kind of like my opinion. But you write your tests. You can write them however you want. They don't have to be, you know, syntactically correct to whatever test framework that you use. You know, the whole goal is like literally what I will do, and I'm not gonna type again to get to avoid the yellow squigglies, but literally you can do is just call your function with the intended input, um, like with the intended input, the intended output, and then you just go through your code and see if you actually get to that output. You know what I mean? Like, and you should be able to do that because in your examples, you should have examples of your input, or of your input going to an output, right? Like, you should have come up with that, So writing tests would be simple, and literally you take your test your test case, you go through it through your code. Obviously a lot of the times you cannot run it, you can't run your code because it's just in a text editor, God knows where, you know but yeah, like you just go through it line by line. You just make sure that you get into it. A lot of the times you will come across bugs in your code. That's fine. Having bugs is not great, but coming across them and fixing them is fine. Like, no one is going to write bug-free code. If that person exists, they're making a quadrillion dollars, or I don't know, they have merged themselves into a computer somehow, and they are Ultron. They are in the internet. So don't worry about that. Everybody's going to write code that is buggy. It's not about avoiding writing code that is buggy. It's about catching those bugs very early on and being able to fix them, and especially doing so with test cases like that you've come up with great test cases. You don't have to be as elaborate. Obviously all of this is um under a time constraint, which I will elaborate about in a little bit. But it's you want to be able to go through your code, check if there's any bugs, and fix those bugs when you find them, and this is where you want to do that. And testing notes, like there may be some issues that that will come up, but is not like for instance, going back to dynamic programming, there are versions of doing dynamic programming where either like you don't have an optimal solution, you have a solution, but it's not optimal, and there'll be test cases where where your solution fails. There'll be, like, for instance, in a lot of, well, there'll be other test cases where your solution is fine up until a significantly large um input, and then it will fail under like a maximum call stack size reached, right? Like, those are things that you can write observations here. It's just great to tell the interviewer that you think about these type of things. You don't absolutely need to. Obviously, if you're writing tests and say you come across a bug, writing your observations here would be great too. You don't necessarily have to. Excuse me. You don't necessarily have to. But just write whatever observations here. Like the notes are here for you. They're also there for the interviewer because obviously, if you're using this skeleton literally in an interview setting, um, the what you call it, the interviewer can see all the stuff that you're writing. Um, yeah, they can see all the stuff that you're writing. Um, but like it's mainly there for you. It's mainly there for you to just kind of put your thoughts on somewhere, and then you can refer to them and you don't have to keep them in your head, right? And that's pretty much the framework. So you write the problem statement in your own words, and you go through examples, and then you make notes on the examples that you've come up with. And this section would be understanding the problem. This section would be proposing the solution. This section would obviously be, well, this section would be proposing the solution and solving the problem, and then this section would be testing your solution, right? And yeah, that's pretty much it. So I kind of want to go through a quick example of of a problem that I went through, um, that I went through, and I used the framework to solve this problem, or a problem that I went through and how I would use the framework to solve the problem. So this is a LeetCode problem. Let me put a word wrap here. This is a LeetCode problem. It's add two numbers, and you're just adding two numbers that appear in a linked list. So actually, I'll just read the problem statement to you. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except for the number 0 itself. Okay, cool. So this is a problem statement. Put the problem statement here, and it's just, you have the problem statement there so you can refer to it. And then these are examples. LeetCode gives you examples, so I put the examples here. Whenever I'm doing LeetCode problems and I'm using this framework, I will literally take the examples from LeetCode and put them there, and then I will think on them. Like I wrote notes here. To be completely transparent, I solved this problem before, without using the framework, and then I put the problem in the framework mainly for this video. But I have several problems that I solved with this framework, and to be quite honest, had I not had the framework, the problem would be, in fact, I had tried to solve several of these problems without thinking about them in this way, and I wasn't able to. Anyways, so I put the examples here, and you have the output, and then like I said, LeetCode has their whole thing about examples. And then I wrote some notes here. So pretty much, you have to reverse them, and then one of the key things in my proposed solution is to make them into strings so that they're easily manipulable, right? Like, I don't want to have to worry about reversing the numbers. Like I know how to reverse strings. I know it's much easier to reverse a string than it is to reverse a number, right? There's a few things I could have done more with this problem, but whatever, right? I just wanted to convert them into strings because strings are more easy to move around. So my proposed solution was to go through the linked list, convert the number into a string, and then add the string to a result, which I will reverse and then return, right? And then add the two numbers up, convert the number into a string, then reverse the string, and then each digit I output each digit in its own linked list. I should have noted that I convert the digit back into an integer, but yeah, right? Return the initial, and then returning the initial node. I like when you're getting linked lists, a lot of the time they don't give you the whole linked list. They give you the first node, and then the node will obviously have the addresses of the other nodes, and you have to just go through them one by one, you know. So when problems say we're giving you a linked list, a lot of the times it's not the whole linked list. It is a single node in the linked list, and then you have to traverse through the linked list yourself. Um, anyways, so my proposed space complexity is O of n. Um, is it O of n? I might have to actually change this. I'll go through this. I don't think it's O of n. I think it's O of 1. Actually, let me change that. Oh, well, you know what? I'll leave it. If it's wrong, it's wrong. It's the exact. The idea is to kind of give you an example of of the framework in use. The time complexity I know is O of n because you have to traverse the entirety of the linked list and then you have to output the entirety of the linked list. There's no way around that. You can't make that any faster. And to traverse and to output the linked list is an O of n operation. You can't do anything better about that. In fact, I make note of that here. And so when I was saying that, there are points where you simply can't optimize the solution any faster. And I have this strange feeling that you can, and somebody's going to blast me in the comments about this. Please let me know. I'll learn from it, but from my understanding, this is the most optimal solution. Anyways, this is the note that I made. It's you have to go through the entirety of the linked list, and it's an O of n operation. Right? Where n is the number of nodes in the linked list I should make note of. And so I just put this under not applicable, but you would do the same thing, right? Like if there was a better solution, I would talk about going through the better solution, and then I would, talk about the space and time complexity of that better solution. Yeah, right. I probably should make a note here why it's optimized space and time complexity. Because you could optimize for space complexity and not optimize for time complexity, even though that usually doesn't happen. You could, so I should probably make a note here as to why it's an optimal solution. But anyways, so and then this is the solution attempt, right? So this is from LeetCode. All of this, the params and so on and so forth is from LeetCode. And then this function, when you get it from LeetCode, is empty. It actually ends here. But yeah, this is generally empty. So let me show the procedure. So this is the procedure, right? Go through the linked lists, convert them, convert the number found into a string, and then return the string that will be reversed, and blah 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 blah, right? So this is pretty much the procedure, right? So you're given two linked lists, and then you have to add them together, and then return a linked list, right? This function is this step, right? List to number. So create an empty string. We take the current node, we make the current node of the list, and then we just go through the linked list, and then we convert the number we get into a string, and we add it, we concatenate it to the current result, and then we just keep doing that, right? Until we come to a current node that's not null, right? Then we reverse the string because I'll talk about this. So then we reverse the string and we return the result as a number. So this converts the result. I just found out about this the other day, to be quite honest with you. But this converts the string the string into a number if it can be converted into a number, and then I'm returning that. So this reverse string is this here, right? So we take the string, we split it, into split will return an array. We reverse the array and then we join it. So we split it on nothing, which pretty much is we split every character into its own array, or into its own item in the array, into its own item in the array. Then we reverse the entire array and then we join it on nothing, which is every every array element. We join it. I'm pretty sure I'm explaining this properly, but yeah. So pretty much this reverses the string, right? Now make note that this is a bit easier to read here. First of all, this is for people who don't write JavaScript, who write, say like C++ or Java. This is in essence the main function, right? This is the main function. When you read this main function, you it reads like English, list to number, right? We want to take a linked list and we want to convert it into a number, and then num to list to linked list. We want to take the number that we have and we want to convert it into a linked list. Like reverse string. I don't care about the implementation of reverse string. Like, I do because I actually had to write it, but I don't care about the implementation of the string. I just want a function that will actually reverse the string, right? And so all of these read like English, and then you can literally have them very much coincide with the procedure you've written, right? And so this procedure, like I said, describes this function. And then the second part, add the two numbers up, convert them, reverse a string, and then output it as a linked list. They are, describes this function. In essence, it describes this function. Well, it describes this function and these parameters, right? But it's very much like English, right? And so you're pretty much transcribing it, and it's just like, how do I make this statement true? How do I make this sentence true, right? And that's pretty much it. I wrote this reverse string when I realized that I needed to do this twice, and I was literally going to write the code twice, and I was just like, what's the point of writing the code twice when I could just easily write a function to do it? And then now it's more readable. Reverse string. I don't need to know how it's reversing the string. I just need to know that it's reversing the string. You know what I mean? And so this this is pretty straightforward, right? I don't need to know the implementation of how it's converting the list to number, as long as it's doing it properly. I don't need to know how it's converting it back into a linked list, as long as it's doing it properly. And this is the kind of code that you want to write and you want your interviewer to see you writing, because this is code that is, I won't say, well, it's close to production code. It's very close to production code. It's what you want to see in production. It's easy to maintain. This is good code to write. This is code that they want to see you write on the job. You know what I mean? And yeah, and that's pretty much it, right? So, I won't go too much into the actual implementation details because they don't matter as much here, but it just kind of matters on how you want the code to look. If anything, I can add. In fact, I'll do that as well. I will add this solution here so that people can rip me a new one if it's actually wrong. But this will just kind of give you an example of the framework in action, right? And then you have your tests here. I won't go through these. I went through this to test this when I was writing this, but I won't go through these here. But you see, like, I have my input kind of defined here, and then like, obviously these aren't linked lists. This is an array, right? I got these numbers from up here, right? So these aren't actual linked lists. So this is where obviously, you can kind of play around. You can say, oh, these are linked lists with these values in them. You know what I mean? Like you can kind of play around with the actual input values, but that's kind of the point, right? The point is, um the point is that you have input values in the way that you want them, and then you just take this, right? So it's like, let me kind of go through something really quickly. Like linked list, the first value would probably be 2, and then we pass the node here, and then blah 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 blah. We check the node, then we get the value from the node. This describes, where is it? Here describes where the value would be. We get the value from the node, and then blah 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 blah, and you just take the input and you just go through your program line by line. And a lot of the times, and this happened to me too, like literally writing this happened to me, where I'm going through it line by line, and then I come across a really silly bug because I am literally saying the thing that is on screen, and it's just like, that makes no sense. And then it's like, oh, there is a bug here, and then, oh, I changed the bug. Now I fixed the bug and it works. You know what I mean? So you want to take your input and you want to have the input go through line by line. You want to be able to start from the beginning of your program to the end of your program and get the result that you want. I forgot to add the result, so let me add the result here really quickly while I have you here. Actually, I think this would be 0. I think this would output 0. Yeah. And this would, let me go get this. I'm sorry, I'm taking up this time. Here we go. Optic blast. Yeah, so this is the result that you're expecting. Again, obviously this is a linked list and not an array that it actually looks like. But yeah, and your whole goal is to make sure that this program, if you take your input and you do the instructions that the program is telling you to do line by line, you would get this output at the end, and then you make notes. I write works as intended. There is potential issue with how I'm creating the linked list for LeetCode. So this is a note that I made. Like generally when you're working with linked lists, especially in production, you're not making the linked list class yourself. You're getting it from God knows where, and then that God knows where usually has a helper function to create the linked list for you. You're not making it yourself. And it's like it will have a bunch of functions and so on and so forth. I have to make the linked list myself because there's no helper function. Unless there is, and I didn't know this. But yeah, so I made that note here, right? A second note that I want to, so one other thing I want to point out before I finish is the use of these functions, right? So I said initially that the space and time complexity is O(n), and I'm pretty sure the space complexity is wrong. But I said the space and time complexity is O(n), right? You have to take into account these functions. These are standard library functions. Like these come with JavaScript. So obviously for your programming language of choice, it will be however, right? But these, you have to have an idea of how fast these functions are. If a function, if your program is O(n), but any of these functions are like O(n) squared, or just something that's bigger than your intended time complexity, it's no longer your intended time complexity. It is the it is your program is as fast as the slowest thing in your program, which may potentially be one of these things, right? So you kind of want to just have an idea of how these work. You know what I mean? Like, you don't have to know exactly, and obviously you can talk to your interviewer and be like, I don't exactly know what's the time complexity of these, like, but you just want to keep that in mind when you're thinking about the time complexity of your program, you know. And maybe you might want to avoid using these if you don't know exactly what they do. You know, it depends. Obviously, you'll have to kind of use your experience with the language, you know, and knowing the time complexity of this does show that you're you're knowledgeable of the language. But I just wanted to bring this up, you know, because it's very easy to be like, oh, my solution is an O of n solution, and you use sort, and sort is, what is it, n log n is an n log n solution, you know. It's an n squared solution if it's small enough, technically, um, for JavaScript. But yeah, like, you want to have an idea of what these functions do, so that, you know, when you're saying this is the time complexity, you're completely accurate, you know, because you're going to get that one person who's just like, you know, this function isn't O of blah 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 blah, and you're just going to sit there and be like, well, darn it. You know what I mean? And it's like, so you didn't get the optimized solution, so we're not going to hire you, get out. You know what I mean? You're going to get that, right? Which would be screwed up, but you know. Anyways, that's pretty much the framework. That's, let me actually go back to this. Yep, that's pretty much the framework in action. You know, like, and that's the end of this video. So I'm going to add I've already added I'm going to add a gist for both the framework skeleton itself, so that you can download it and start using it. What was the other thing? I'll also add a gist for the problem that I showed in this video, to kind of as an example. um Feel free to critique the problem. You know, feel free to tell me that I could have done it better or worse or whatever. Absolutely feel free to do that. Like, if the problem is wrong, or if anything that I say is wrong, please let me know. You know, obviously I am learning along with me attempting to teach everybody. um what else did I want to say? I think that's about it. Thank you very much for taking the time to watch this, and have a good one. Later.